Good morning, students. I hope you all are well and doing mathematics comfortably. These days, we people are doing how to find the intrinsic equation Nez Samikaran of the given curve. Yesterday, we took the example how to convert the Cartesian equation of the curve into intrinsic equation. Today we consider parametric equation of the curve and how to convert it. So you just look at the example. Taking origin as the fixed point, find the intrinsic equation of the cycloid. The equation of the cycloid is given. This is parametric equation of the cycloid. We have already done. Hence prove that rho square plus s square equals to 16a square. Rho, here it is radius of curvature. This is given in differential calculus. हिंदी में इसको वक्रता त्रिज्या बोलते हैं. And this is given by ds by d psi. Remember this. Intrinsic equation, a relation in rho, in s and psi. A relation in s and psi is known as intrinsic equation. This we have done with respect to Cartesian equation. Now this is parametric equation. Then how to simplify this one, how to obtain this particular one. So this is the relation in s and psi, and the arc length is measured from the fixed point, and here origin is the fixed point, and here t is given minus pi to plus pi. Okay, this part is given to us. Cycloid. This is x equals a times p plus sine p. It is not minus, remember, and y equals to a times 1 minus cos p. P is the parameter here. We have discussed the graph of the cycloid, and here the graph is not required. Even then, as usual, as I explained yesterday, this is any curve. A is the fixed point and P be any point on the curve, and the tangent is drawn. This is psi, here it is P, maybe xy or maybe r theta, whatever it is, and this is s, that is AP. So length of the arc is measured from the fixed point A here. So if Cartesian coordinates, then it is xy, polar coordinates, then it is r comma theta. So here we people are given parametric equation, and the diagram of this one is again. I am telling you, it is not required. This is the origin. This is pi. Here it is minus pi. This is the circle. Okay. And this is the fixed point. Suppose here P be the point, and this is S. Arc is measured. So here arc OP, that is equals to S, and this is the parametrics are right. It is T1 to T2. Under root of dx by dt whole square plus dy by dt whole square of t. This formula we people know that. Now we simplify this one. So first we want to find dx by dt and dy by dt. So let us see. X equals a times t plus sin t. Look at the sign is plus. If it is minus, this is also minus, both negative, then the cycloid will be just like this. It was explained. Okay, so here it is this. So dx by dt, differentiation with respect to t, it is a times 1 plus cos t y equals to a times 1 minus cos t. So dy by dt, this is a sin t. Therefore, dy by dx equals to dy by dt upon dx by dt. dy by dt is a sin t, a into 1 plus cos t. This is cancelled out. This is 2 sin t by 2 cos t by 2 upon 2 cos square t by 2. Use trigonometry. Okay. This is 10 t by 2. So dy by dx is 10 t by 2, but 10 psi is dy by dx. Therefore, 10 psi is 10 t by 2. This implies psi equals to t by 2. We have to find the relation in s and psi. So this is a function of t. When we calculate it, it is a function of t, and this is also a function of t. So we can eliminate t and we can find the relation in psi and s. Okay, so now s equals to this is like equation number 1. From equation first, 0 to t, under root of, remember it is t1 to t2, but it is from origin, and at any time the position of the point is p, and here it is from 0 to t. So you remember it is dx by dt. Dx by dt is, here it is a square 1 plus cos t whole square plus, look at this, this is dx by dt, and here it is dy by dt. So we place the values of dx by dt and dy by dt in this particular formula, and we found it is a square sin square t. Integration is with respect to t. If Cartesian coordinates, then it is 0 to x. If it is dy by dx, yesterday I explained. If it is in terms of y, 1 plus dx upon dy whole square, and integration is with respect to y, then we take the limit 0 to y if origin is fixed, 0 to x if origin is fixed, and parametric equation, and again if the origin is fixed, then it is 0 to t. Otherwise the limit will be changed. Okay, so here it is given. This is 0 to t, little bit simplification. A square and this a square common, so here it is a. This is 1 plus cos square t plus sin square t is 1, so it is 2 plus 2 cos t. You simplify yourself. 0 to t under root of 2 times 1 plus cos t dt. This is 0 to t under root of 2, and this is 2 cos square t by 2 of t. Okay. Right, this side. This is 2a 0 to t cos t by 2 dt. Now the integration is sin t by 2. Limit is 0 to t. Integration of cos is sine, but here you see the coefficient of t is 1 by 2, so we divide the result by 1 by 2, so it will be 4a sin t by 2. Now upper limit is t, so there is no change in the first part. Sin 0 is 0, so the final answer is 4a sin t by 2. Okay. Therefore, s equals to 4a sin t by 2. We want to find the relationship in s and psi. And here s is a function of t and here psi is a function of t. So we can eliminate t. Suppose this is number 2. So from 2, s equals to 4a sine. Now t by 2 is replaced by psi. So it is 4a sine psi. It is very important relationship. So the intrinsic equation of the cycloid is given by s equals to 4a sine psi. Now we prove the remaining part of this. Rho is the radius of curvature, and this is given by ds by d psi. Now rho is ds by d psi. So we differentiate with respect to psi, so it is 4a cos psi. 4a cos psi. Therefore, rho square plus s square equals to rho square is 16a square cos square psi plus s square is again 16a square sin square psi. 16a square is common, and this is cos square psi plus sin square psi. This is 1, so this is 16a square. Therefore, rho square plus s square equals to 16a square. Henceforth. So this is the example in which we found the intrinsic equation when the equation of the curve is parametric. So we have done two types of example. First, when the Cartesian equation is given, we took the example y square equals to 4x, that is the parabola. Then how to find the intrinsic equation? Today we took the example in which the equation of the curve be given in parametric form. You remember sometimes parameter is given theta, x equals to a times theta plus sine theta. You remember this theta is different from that theta which is given in polar coordinates. So be careful, here t is parameter, instead of t it may be theta. So here it is x equals a times t plus sine t, y equals a times 1 minus cos t. So here t is parameter, and this is the parametric equation of the cycloids. Now the last example, we consider the equation of the curve is given in polar. Then how to find the intrinsic equations? Okay, so let us see. We consider the curve cardioids, and equation of cardioids, you people know that the polar form is the simplest form. taking pole, that is dhruv, taking pole as a fixed point, find the intrinsic equation of the cardioid R equals A times 1 minus cos theta. R equals A times 1 minus cos theta. If theta is 0, then cos 0 is 1. And theta is pi, then it is minus 1. So definitely the shape of the cardioid. Again I am telling you, the shape is not required. Even then, I draw the figure. It is this. This is the pole. Be any point r comma theta, and let P r comma theta be any point from the pole and its distance measured from the fixed point pole is S. Therefore, OP is S, and this is 0 to theta in terms of theta. Okay, this is under root of, you know that it is r square plus b dr whole square. So let us say r is A times 1 minus cos theta. Therefore, dr by d theta is A sin theta. Also, then phi is r d theta by dr. R is A times 1 minus cos theta. This is 1 upon A sin theta. So A is cancelled out, and this is 2 sin square theta by 2 upon 2 sin theta by 2 cos theta by 2. This is tan theta by 2. Okay. Therefore, phi equals to theta by 2. Remember, this theta is not parameter. The theta is in the form of polar coordinates. Okay, so this is the vectorial angle. So tan phi, we people know that r d theta by dr, and simplifying this, we found phi equals to theta by 2. Also, we know the formula psi equals to theta plus phi. Theta plus phi is theta by 2, so it is 3 theta by 2. We want to find the intrinsic equation. हमें नैज समीकरण निकालना है, इसलिए s और psi में रिलेशनशिप चाहिए. s यहाँ से मिलेगा, ये थीटा के टर्म्स में आएगा, और psi जो हमने कैलकुलेट किया वो भी थीटा के टर्म्स में है. जैसे पहला वाला एग्जांपल था, टी को हमने एलिमिनेट किया था, यहाँ हम थीटा को एलिमिनेट करेंगे. सो लेट अस कंसीडर दिस. This I consider as equation number 1 and this is number 2. So I consider this, okay. Therefore, from first, this equals 0 to theta under root of r square means a square 1 minus cos theta whole square plus d theta by dr. I think it is 1 upon a sin theta. R is a times 1 minus cos theta. This is R is dr by d theta is a sin theta. Okay, so this is dr by d theta. So this is a square sin square theta. 0 to theta. A is formed. A square set will be a. Then it is 1 minus 2 cos theta plus cos square theta plus sin square theta with square root sin d theta. 0 to theta under root of, this is 1, so it is 2 times 1 minus cos theta d theta. This is a times 0 to theta under root of 2 into 2 sin square theta by 2 of d theta. Okay, so this is 2a 0 to theta sin theta by 2. This is 2a minus 2 cos theta by 2 0 to theta. So this is minus 4a cos theta by 2 0 to theta minus 4a cos theta by 2 minus 1. This is 4a 1 minus cos theta by 2. Okay. And this is 4a 1 minus cos theta by 2. And see, theta by 2 is psi by 3. This is cos psi by 3. Therefore, intrinsic equation of cardioid r equals a times 1 minus cos theta is as equals to 4a 1 minus cos psi by 3. Okay, so this is the way to find the intrinsic equation of the curve when Cartesian equation is given, parametric equation is given, and polar equation is given. So I hope you have understood. Thank you very much. Jai Hind.